Ugh, not again. My app just froze in the middle of a transaction. Why does this always happen?
You know, that frustration you're feeling? It's super common, and it actually gets to the heart of what makes software, well, good. It's not just about finding bugs. We're talking about a core quality called reliability.
So let's unpack that. Because reliability is one of those words we all use, but in software, it means something very specific. It's way more than just the app not crashing.
Okay, so check this out. The official definition is all about how a system performs a specific function under certain conditions for a set amount of time without failing. The key takeaway here is that it's about being predictable and consistent every single time you use it. Here's a great way to think about it. Let's compare functionality and reliability. Functionality is basically asking, does this feature do the right thing? Like, can you ever complete a purchase? But reliability asks, does it do the right thing consistently? Can you complete that purchase every single time without a hitch? That's the real game changer. All right, so I get it. It's super annoying for me as a user, but why is this such a massive deal for the companies that actually make the software? That is the million-dollar question, isn't it? And, you know, there's this great quote from a software expert, Jerry Weinberg. He basically said, if you think testing is expensive, try not testing. The question isn't, is testing affordable? The real question is, compared to what? And that what is the huge cost of failure. For companies, the stakes are incredibly high. We're talking everything from straight-up financial loss to completely tanking their reputation. I mean, would you trust a bank whose app always crashed? It can even lead to legal trouble, or in the most extreme cases, total catastrophe. And this isn't just theoretical. Take the Hitomi Space Telescope from 2016. A software fault made the satellite think it was rotating when it wasn't. So what did it do? It fired its thrusters to fix the problem, which, of course, sent it into a real, uncontrollable spin until it literally broke apart in space. And the price tag for that one software glitch? $273 million. Gone, just like that. That's what's at stake.
Wow, okay, that's a huge cost. So how on earth do developers even start to check for reliability? I mean, you can't just sit there and click every single button, can you?
Exactly. You're right. It's not random at all. Achieving reliability doesn't just happen by accident. It's the result of a really well-planned, systematic testing process.
It's all about a fundamental process. First, you have planning and design. This is where you figure out what you're going to test and how. Then, you actually do it. That's test execution. And you log everything. And finally, you analyze what happened, fix the problems, and then you test it all over again. It's a constant cycle.
Okay, so you mentioned test cases in the planning stage. What does one of those actually look like in the real world?
This is a perfect, simple example. Let's say we have a feature that gives a discount on a car based on its price. You don't just test it once. You create specific test cases, like what happens at $14,000? The discount should be 0. What about 19.5? Should be 5%. Each row is a specific test with a specific input and a specific expected result. That's how you prove it's reliable. Man, that seems like an incredible amount of detail-oriented work. So on a typical project, how much time and effort is actually spent on just this kind of testing? You might be surprised. It's a huge chunk. As a rule of thumb, testing and quality assurance can take up anywhere from a quarter to even half of the entire development effort. Think about that. For a lot of teams, that's a huge investment. So really, here's what it all boils down to. That reliable software that you use every single day, it didn't get that way by accident. It's the result of a massive, intentional, and frankly very costly effort. It's a huge investment. But like we saw, the cost of not doing it is way, way higher. And that actually brings us to a fascinating and kind of scary future challenge. How do we keep software reliable when it's powered by AI? I mean, with artificial intelligence, sometimes we don't even know how it's making its decisions. So how can we possibly guarantee it's reliable? That's the next frontier.